Let's talk about finding volumes between these figures and these figures and these figures using multiple integrals. So I'm going to start with the first one. What I want you to notice is how I've organized it. Let's look at the problem first. So the first problem is in blue here. It says find the volume bounded by the planes z equals x, y equals x, and y equals 2 minus x, and I'll figure this out in just a minute. The second one is find the volume bounded by the cylinders z equals x squared, y equals x squared in the planes z equals 0 and y equals 4. And then the third one is find the volume of the solid enclosed by these two cylinders right here, y equals 1 minus x squared and y equals x squared minus 1, and two planes in the z direction. These are oftentimes the hardest for students to understand how to figure out the limits of integration and even in the integrand. And what I want you to note is that the integrand here is always what, as long as they're using dy dx, the integrand is always what's going on in the z direction. So let's see what this looks like graphically. For the first one, what I've done here is I've done my three examples here, and in order so they all contain, the constituent functions. Okay, the way I created these was I just did this plus sign. I said folder, I say example maybe, and then once I start plugging in z equals y squared or something like that. Once I start plugging in functions here, I want to make them part of this example. So what I can do is I can just take this and just drag it over. Take this and just drag it over. And if you see these two lines here, say that they go with that example. Okay? And so now whenever I want to just not show this example, I just can click on the little folder, and now it's just this planes example that's being shown. Or if I want to show this example, the second one, I just click on that one, click off of that one, and now I have this, just the parabolic cylinder example 1. So let's go back to this one here, the planes example. The question is, find the volume bounded by the plane z equals x, y equals x, and y equals 2 minus x. So for the student, what can happen, let's just go ahead and open this up. I have z equals x, y equals x. Z equals x is the red, y equals x is the blue, and then the green is x plus y equals 2. The green is this one here, and the blue is this one here. All right, so if I take off the y ones, if I take off these two, I see what's going on in the z direction. And so it looks like from z equals 0 to z equals x, this z equals x, that's what I'm going to put in the integrand right here, x minus 0, if you will. What I've also done, and what you just saw me do here, is I put this also in Desmos, regular Desmos, to see what the limits of integration should be. So it looks like I'm going to go in the x direction, so I'll just do like y, it looks like y equals 2 minus x and y equals x. So I'll probably just do the blue minus the red in the x direction. So that this Desmos example goes along with the planes example that I showed before. And in the next video, I'll show you what I did with the other examples. So if you look down upon it, let's just take out z for a second. If you look down upon it, this is exactly what I'm seeing in the example. I should probably make this one, make them the same color. So blue and green. So green is going to be, this is going to be blue. And the other one's going to be green. And now they line up with the same colors. So it's what's right there that I've got to integrate over. And that is what's going to go in these spaces right here, the limits of integration right there. So look for the other examples in the next part of this video.